All right, kids. Good morning. Happy Monday. Beginning of quarter four. This is very exciting. We are 3/4 of the way done with the school year, and we have a new thing with our students. We have some more students coming in person, both in fifth and sixth grade, which is great. We have all of you at home who are working with Miss Kresick. So your class has gotten a little smaller, but you got the same deal. We're still going to have all of our lessons from myself and from Miss Erickson and from Dr. James and from Miss Kresick. So it should be kind of fun. And what we're going to kind of do this quarter is work hard, make sure we're doing all the little things along the way so we kind of can keep up and finish strong, finish on a good note with our grades for quarter four. And, for my grades, I put in a lot of grades every week. I don't put them in every week, but I give you a lot of shorter assignments, which means it's really good to keep up with the little things like a note card. Keep up with these and they will help you. Okay, so today's note card, solving one-step equations. The last couple of weeks we've been talking about tables and graphing and linear versus nonlinear, all of that stuff. Super important for sixth grade. But another thing that's really important is solving equations. And I'm going to show you how to solve four different types of one-step equations today. And I'd like you to, in your notebook, the date, what do we got? It's 4/19. So put the date in your notebook, right? And you can say Monday just to make it clear, right? And we want to, Monday, 4/19/21, we want to write one-step equations. And then I drew this little diagram and I put on one side 5 plus a, and on the other side I put an 18. Now that equal sign represents that these two things are in balance. The 5 and a is on one side, I'm holding it, and the other side is an 18, and they are exactly even. That's what that equal sign means. An equation means equal. So the two sides of our equation are equal. 5 plus a is the same as 18, which means that the a, the unknown, which is easy in this case, but it's something unknown, must be a number that will allow these to be balanced. So right away, you guys are like, oh yeah, it's got to be 13, right? 5 plus 13 would give me 18, and that would be correct. A in this case is 13. So they have to be in balance. So we would say an answer to that balance question is a equals 13. Now, I'm going to show you how to do this just with a series of examples. The first one we're going to do, let's see here, let's draw in a grid here, like separate this. So we're going to start a grid right here. I'm going to cut this into 4 equal parts. We're going to do, let's see here. The first one we're going to do is the addition equation, one-step equation addition. Remember, you want to write all this into your notebook. So the first one we're going to do is addition. So maybe I'll write that down aside. This will be fun. Let's try this. Let's see if this works. Look at this. Let's see if this works. It's going to look really goofy, but it looks like it kind of works. This is an addition equation. Okay, ready? For addition, we're going to do just like we did up there. I'm going to write in J, right? Plus 5, we'll use 5 again, why not? J plus 5 equals 12. And I'm going to go back and change that one. Equals 12. Now, the way I solve this, in your head, you're probably thinking already, I know what J is. J must equal 7. 7 plus 5 equals 12, right? And you're correct. That's how we do it. Now, I'm going to show you the steps in terms of how I want you to write them. So when I show you the steps, I'm going to show them in, I'm going to say, well, if the problem gets more complex, you do something else. If I want this 5, this J and the 5 are together, I want them separated. I want the J all by itself. I want it alone. So what I do is I take 5 away, right? And I take that away because I want that j to be alone. So 5 minus 5 gives me 0. Remember, if I have plus 5, I go minus 5. So if I do something to one side of the equation, one side of the balance, like if I take 5 away from one side, in order to keep things in balance, remember the whole picture up here, in order to keep things balanced, so in order for this to stay, I need to take away the same from each side. I need to take that 5 away from both sides. So then I'm going to draw the line. I'm going to say, okay, well, if I take away 5 from both sides, now I'm left with just the j, right? The 5s cancel each other out. So what I do there is I could write plus 0, but what's the point, right? It's gone. So I don't really need to write that. I can actually just kind of say that disappeared. But on this side, I still have something. I have j on this side. And on this side, all I have, 12 minus 5 gives me 7. So that's all I do. That's a terrible looking 7, but okay, we'll just leave it like that. J equals 7. And then I check it. Does 7 plus 5 equal 12? Yes, right? Easy, totally easy. That's an addition equation. Okay, now we're going to do a subtraction one. And I think the longest thing about these types of problems is going to be writing in subtraction like I want to. This is a subtraction. Let's see if I can fit it. Let's just say subtract because I'm going to run out of room. Subtract. Okay, let's do another one. This one we're going to go, and this one's different. We're going to go k, and I'm going to have to k minus 8 equals 12. And by the way, all of this up here, that's all something else. So if you want to go back and like show on mine, I don't have a whole lot of room, but show that this is like part of the title, right? Just so we kind of know that's a different thing. This is a new problem here, the subtract. So k minus 8 equals 12. Well, in this case, same deal. I now have to think of a number bigger than 8, clearly, that would give me at the end 12. Something minus 8 will give me 12. What could that be? So in order for me to figure it out, I can think about it and be like, oh, it must be 20, right? 20 minus 8 equals 12. Okay, good. K equals 20. Or I can actually take the steps. And the steps are, I see a minus sign right here. So what do I do to get rid of this? I add 8. Notice I'm doing the opposite of what I see. I want the k to be all by itself. So I add the 8 to both sides. And I think of equations kind of like I think of a fraction. If I do something to the top of a fraction, in order to keep it equal or equivalent, I have to do the same thing to the bottom. Like if I divide the top of a fraction by 2, I got to divide the bottom by 2. If I multiply the top of a fraction by 2, I got to multiply the bottom by 2. You know, it's like when we make an equivalent fraction. Same thing here. Equations are about equivalency or equal, keeping things equal. So in this case, we're going to do the same thing we did on the addition equation. We're going to say, well, I see minus 8. Therefore, I need to add 8. I need to make it positive 8, right? And those two go away. They are canceled out. So all I have left is k equals, right? The 8s are gone. 12 plus 8 equals 20. And then I check it. Does, and I like to check. So over here, I can write it, maybe a little here. I'm going to write check, right? Does 20 minus 8 equal 12, right? And it does, right? That's a check. It works. It works. It works. Same thing over here. If I want to check over here, I would say, does 7 plus 5 equal 12, right? And that's a yes. So those work. And these are all like, we check it afterwards. We check and see if it works. So it's like we do our work and then we say, does it work? Oh, yes, it does. All right. Now we're going to do our multiplication. I think I have to make my face smaller. There we go. Oh, getting small. Okay, we're going to try multiply. Now, it keeps multiplication is actually not too hard. But the division that we're going to do last is a little harder. So let's do multiply. These are multiplication. And over here, we're going to do divide, right? And the division ones, I think, are the trickiest. Okay, division equations. Okay, so for multiply, let's do it. We're going to do, we did J, we did K. Let's do L. So L, cursive L, times 4 equals 32. Now, once again, I know you guys are like, all right, whatever, this is easy. What number times 4 would equal 32? And you're thinking, oh, it's 8. Why do I have to do all these steps? And you're kind of right. You're absolutely right. Why do we have to do all these steps? Well, let's just keep doing them. I'm going to show you why, because when we get to the next step of this week's problems, when we do two-step equations, it becomes really important to recognize that we need to get things detached. Like I need L to be by itself, just like I needed J and K to be by themselves. I need L to be by themselves. So how do I get rid of a times 4? Right? So to get rid of times 4, I do the opposite. Just like here I did plus and minus, over here I do multiply and then I divide. Divide by 4, I put it underneath. And over here I do, because it's on the same side, on the other side, I have to do the same thing. I divide by 4. I come back, I draw my line, right? And now notice, this is a multiplication of problem, but what do? I do the opposite. I divide. So 4 divided by 4 would give me 1. And this is a little tricky. So this is 1. This is my L. So I'm going to write L times 1. Make sure you distinguish between the L and the 1. And then on this side, I'm going to say 32 divided by 4 equals 8. So now I say, well, what's 1 times L? Isn't that the same as just saying L? 1L, or 1 times L, is the same as saying L equals 8. And that's my answer, L equals 8. Now we check it. So let's go down here. and we write check, and we go, okay, let's plug in 8 for L. 8 times 4 equals 32. Is it true? Yes. Check. 8 times 4 equals 32. Think back to your math facts. You're like, we got this, no problem. All right, the hardest ones. Oh my gosh, these are the hardest ones. Are you ready? Division. I'm going to give you M, J, K, L, M divided by 3 equals 9. Now I'm going to show you another way to write this. This one's going to take a little more work. Another way to write M divided by 3, and the way you're often going to see it, almost always going to see it, is going to be M over 3, like it's a fraction. 1m on top of 3 equals 9. Now, think about this problem for a second. In order for this to be true, where the number we finish with is a 9, it means this m has to be bigger because it's being divided by 3. Okay, so what do I do here? Well, this one's a little tricky. This one's harder to draw too. It's harder to show. What I'm going to do on both sides here is I am going to multiply. I'm going to put this in parentheses, and I'm going to multiply this whole thing by 3. Okay, now if I multiply this side by 3, I also need to multiply this side by 3. Okay, kind of a pain, right? But okay. Now parts of those are easy, part of them are hard. So the easy side, 9 times 3, right over here, this equals 27. That part's easy, right? That's good. This side gets a little trickier. How do I do 3 times m over 3? Well, the way we do it is, this is actually 3 over 1. So another way to write this is to write 3 over 1. Because remember, 3 and 3 over 1 are the same. And if I write 3 over 1 times, and I'm going to go back to black so you see that we started with, times m over 3, right? And then multiply across, what I end up getting is 3m divided by 3. Now, this is a good thing. And once again, I told you there's a lot of steps here, but it's not that hard. What is 3m divided by 3? Well, that would be 1. 3 divided by 3 is 1. So this would give me, these cancel out basically. So those two 3s, they basically just like, here, let's make orange. These just kind of cancel out. You know, the 3 and the 3 cancel each other out because 3 divided by 3 gives me 1. So what I'm left with is just m equals 27, right? And that one took a lot more space than the other ones. These are the hardest ones to do with one-step equations. So m equals 27. And then over here, I'm running out of room, but we're going to check it. And checking it will actually work better, actually won't be that hard. Is 27 divided by 3 9? Well, yes, it is. Ta-da! And that's it. So our answers in all of these cases, we get a single number that solves our equation. One number will solve our equation, and that's what one-step equations are like. So addition and subtraction, pretty easy. Multiplication, not so hard. We do the opposite. But division, a little bit of work here, a little bit of work. So we want to get used to that. So make sure you write this down clearly, and we'll do more practice. And you have a little puzzle maze to do that goes along with this type of work. Okay? All right, guys. Have a great day.